The main message in my talk is by using this ultra-high vacuum, low temperature, keep enhanced Raman scattering technique, we are able to push the spatial resolution of Raman mapping down to sub-nanometer scale. And I think this is very important for the future study of surface science, photochemistry, or even biomolecular imaging.
I'm very happy that finally our program chair, Mike George, arrived from China. So Mike, we are very happy that you're here because it's difficult to run a conference without a program chair. I'm glad that you're here safely, and this is
Thank you.
the t-shirt.
I hear that the program has, from the number of people who've stopped and said it's gone fantastically well, I'm glad it is. I'm just sorry I missed the talks, but I'm looking forward to the ones that are coming up.
So in my group we develop a new laser systems which are called laser frequency combs, and that's lasers which have a very broad spectral span and which are made of very narrow and equidistant laser lines. These lasers are interesting for new approaches to molecular spectroscopy, and in particular one can perform Fourier transform spectroscopy with two of such lasers, and that provides a spectrometer without moving parts, which is much faster than the conventional Fourier transform spectrometer. It is 1 million times faster, and that's also more accurate, more sensitive, and we are trying to explore what is the new potential which is opened up by this type of lasers.
That is surface-enhanced infrared spectroscopy, and it's quite an honor for me that the pioneer in this field, Osawa Sensei, is here in the audience.
Well, for us as a Raman instrument producer, the ICAVS and the ICAVS are two core conferences. When I think, okay, where would I check out new instruments? Well, if I were to shop for one, those would be the conferences. Here we have the Apeiron, the fully automated Raman platform, which now allows the user on the click of a mouse to do all you need for Raman imaging, Raman spectroscopy.
I presented a new technique that we developed over the last couple of years that brings infrared imaging and spectroscopy down to the nanometer scale. So up to now, imaging spectroscopy is limited to the wavelengths range, which is in a micrometer scale. But if you want to really see nanostructures, then we need to beat this diffraction limit by orders of magnitude. And we achieved that by actually scattering light at an AFM tip and collecting this light and recording it as a function of the spatial position. We commercialized this tool, and one of our customers actually used this tool to look at stardust and to analyze what is inside the stardust with the help of infrared microscopy and spectroscopy, and they can do this now on a scale on nanometer scale, which has been impossible up to until now.
And so we have a kind of little animation where we zoom into a spectrum, and in the meantime, to give an equivalence to the audience, we show the same magnification of zoom into the Earth. In the beginning, the Earth planet, and at the end, a guy who is lying in the grass after a picnic, and we have the same degree of magnification in the spectrum. So it means that we are able to see really tiny details which are very precise and very accurate.
This is a great conference. I mean, you can come here, you see old friends, you meet new friends, and you listen to many different talks. And I think that will help you the research of your career in many different ways. And I think this kind of thing, the conference focus on specific topic, will give you understanding and also the latest message about the development in the field.